Hey guys, this is Dr. Brown with Kubo Math coming to you from Tarlac City, Philippines. And tonight we've got 5th and 6th grade math. And let me tell you, they had some awesome problems. So we're going to take a look at some and see what we can do. Okay, let's get after it here. All right, they had the study is in factors and multiples. And then we have one problem dealing with the exponentials that we learned last week. So, and we may actually at the end of this, after the exponential problem, review exponents, and see if we can recall what happened last time. Okay, a pair of factors they're looking for of 368 whose sum is 39. Now you know when you're dealing with factors, it's, let's say I have the number 10. We could say what can divide into that evenly? Well, 10 divided by 1 equals 10. 10 divided by 2 equals 5. And 3 won't work. 4 won't divide evenly. It becomes out a remainder. So these would be 2 and 5, 1 and 10 would be the factors of 10. So that said, they're asking us for what are the factors of 368. So I'm going to take 368 and divide it by something. And whatever I divide it by plus my answer, it needs to be 39. Let's assume for a moment this is 400. Okay? And I'm dividing that by 2. Well, 2 will go into 400 200 times. 200 plus 2 is 202. So I know I'm way off in my guess on this number. Now I know this is not 368, but I'm just trying to get a feel for about where are we. Well, what if I said 10? I'll jump up to 10. Well, 10 will go into that 40 times. 10 times 40 is 400. And then 40 plus 10 is 50. Oh, I'm getting closer. So maybe it's somewhere 12, 14, somewhere in that range. So let me just go back to this now. And let's say 12. Well, 12, 24, 36. Be 36 and 8, that won't work. So I end up with an 8 in a remainder here, so it doesn't go in evenly. So let's think, well, let me jump up to, can't be 15 because this is not a 5 or a 0. You know, it's not a multiple of 5. So let me try 16. Okay, 16 times 2 would be 32, and then that 2 from 6 leaves me 4, 48. This is it. 23. 3 times 16 is 48, no remainder. And now 16 plus 23. 3 plus 6 is 9, 2 plus 1 is 3. So the pair of factors of 368 whose sum is 39 is 16 and 23. Okay? So that's how you would solve that one. This next one is a good problem. Jim is less than 60 years old. Oh, he's younger than me. I'm 64. All right, his present age is a multiple of 9. When you think about multiples, you're saying, let's say I have the number 10. Okay, well, that's 10 times 1. What's 10 times 2? That's 20. 10 times 3, 30. 10 times 4, 40. These would all be multiples of 10. You just take 1, 2, 3, 4, 5 times whatever number you're looking at, and that would be considered a multiple. Now, his present age is a multiple of 9, so that means this year. Last year, his age was a multiple of 5. Now that means whatever the multiple of 5 was, that's within 1 digit of this year, because he was 1 year younger last year, 1 year older this year. So they're asking, how old is Jim now? So let's write the multiples of 9 and the multiples of 5 and see when there's 1 unit difference, 1 year difference between the two. So we'll put last year as one column, this year as another column. So last year, let's see, he's less than 60. So he could be 5 all the way till 60, right? So last year he was 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. Says he was less than 60. So if I put 60, he's less than that. So it would have to be one of these. Now his present age is multiples of 9. So now, last year. This year, present age, I should say present age, same as in the problem. Okay, it's multiples of 9. So now we have 9 times 1, 9 times 2, 9 times 3, 27, 9 times 4, 9 times 5, 9 times 6, 9 times 7. Okay, so I won't have that one. He's less than that age. Now, let's look and see which of these are 1 year apart, with this one being 1 digit, 1 year higher than this one. So 25, 27, that's 2 different. 30, 36, don't have it. 35, 35 last year. 36 this year. That's 1 different. Are there any other options here? 40, 45, 45 is the same. So he didn't age, so that doesn't work. 50, 54. So he was 35 last year. He's 36 this year. So Jim would be 36 years old. Okay? That is an example of multiples. The first one was example of factors. Okay? Number 3, a pair of factors of 240 whose difference is 1. Okay? 240. We're trying to find factors of 240 that their difference is 1. Well, if I put 10 here, this would be 24 times 10 gives me 240. Well, obviously, I'm way off, right? Let me try jump up to 15. 15. So 15 to go into that one time. So that gives me 9 different. Bring down to 0. And 6 times 5 is 30. Yeah, that works. So 16 and 15, and their difference is 1. 16 minus 15 is 1. So this would be 16 and 15. That would be factors of 240 whose difference is 1. Okay. All right, one last problem that is really cool. I'm going to erase a little bit here. Get us some room to work. Okay, we have a problem that says A times A equals 400. It also says A times B times 10 equals 3,400. Now, actually, I'm going to remove the X and put a dot. I'm going to put it like this, okay? And that kind of cleans it up. It's the same thing. Even A times A, the dot's assumed, the X is assumed, okay? So A times A equals 400. A times B times 10 equals 3,400. So they want to know, what is B? B equals what? We learned last week about A times itself. Any number times itself, you count how many times it's multiplied by each other. Like A to the second power is A times A, which is exactly what we have here. So it's A squared, or A to the second power. So we can write that 400 is A to the second power. So I'm going to just say that equals A to the second power. Okay? Now then, we have A times B times 10. You could rewrite this as AB, or 10 AB. That equals 3,400. Well, I'm going to divide both sides by 10 and get rid of that 10. So 3,400 divided by 10 gives me A times B equals 340, because, you know, the zero wipes out there. Okay, now then, we know A to the second power equals 400. A to the second power equals 400. To get the square root of a number, I can take and do this to both sides. What you do to one side, you do to the other side. The square root says what number times itself gives me A to the second power. Well, we know it's A. So the square root of A squared is A. And that equals the square root of 400. Now, since they're wanting to know what B is, I need to actually get a number for A. Now, one of the rules in square roots, if I have the square root of X times Y, you can break that into two pieces. It also equals the square root of X times the square root of Y. Let's challenge that. Okay, so let's say I have the square root of 9 times 4. Well, 9 times 4 equals 36. So we're saying the square root of 36 is 6. What number times itself gives me 36? Well, it's 6. 6 times 6 is 36. So the square root of 36 is 6. Okay, now, this rule is saying I could take square root of 9 times square root of 2. Square root of 9 is 3. I'm sorry, square root of 4. I've got ahead of myself for the answer there. Okay, square root of 4. All right. Okay, square root of 9 is 3. Square root of 4 is 2. 3 times 2 equals 6, which is the same as what I had earlier. So that said, I can factor this 400, and we've been factoring. Hey, so we're learning some tools that we can use here. So A equals the square root of 400, which is what? 40 times 10. Hey, and you're thinking, well, what? We're not there yet, so no, not yet. Okay, so A equals square root of 4 times 10, which would be 40. 4 times 10 times this 10, which was 4 times 100, which I should have probably just jumped to that already. Okay, well, that equals Square root of 4 times, what's 10? It's 2 times 5. What's this 10? Well, it's also 2 times 5. Can you see what's happening? Hey, we've got the square root of 4, this 4. 2 times 2 is 4, so that's times square root of that 4. 5 times 5 is 25. So we have the square root of 4 times the square root of 4, which was that 2 times 2, times the square root of 5 times 5. Now we're almost, okay, so we have 2, square root of 4 is 2, that square root of that 4 is 2, square root of 25 is 5. 5 times 2 is 10, 10 times 2 equals 20. A equals 20. Can you see that down there? Okay. Can you see that? Right, yeah. All right, so A equals 20. All right, we had AB equals 340. A times B equals 340. If we divide both sides by A, this A canceled. B equals 340 divided by A. We just said A, we solved it. A is 20, so B equals 340 divided by 20. And that would equal, B equals, the zeros canceled, 34 divided by 2 is 17. Well, not yet. Not yet. We need to check it. Okay, we have A times A equals 400. So we know 20 times 20 gives me 400. Now we have 20. We have A times B times 10 equals 3,400. Okay? So 20 times 17 times 10, they're saying is, so 17 times 10 is 170. Oh, sorry, 340, 20, 1 is 20, 14, bring down to 0, yeah, 17. All right, I thought I'd messed up there. 17 and then 20 times 17, 2, 0, 14, leaving the 1, 2 down 1 is 2, and 1 is 3, equals 3,400. Now, so what was B? B is 17. Okay, what did we use here? We used a concept, a new rule maybe for you, but it was the concept of the square root of x times y can be broken out as the square root of x times the square root of y. That allowed us to factor that 400 and break it down into various pieces, take the square root of each piece. Of course, we factored it way down, 4 times 2 times 5 times 2 times 5. So it was 2 times 5 was this 10, 2 times 5 was that 10. But then I combined the 2's to get one of the 4's, and then 5 times 5 gave me 25. But that was an example of a new square root rule. All right, this was a good problem. So factoring and multiples, and then now square root. Oh, I told you maybe we study a repeat on what we did last time. I did this today. What's 4 to the second power minus 4 to the first power plus 3 million to the 0 power? Okay, 4 to the second power is 4 times 4, right? 4 to the first power is just 4, plus 3 million to the 0 power. Do you remember that rule? Any number raised to the 0 power is 1. It wouldn't matter if this was a billion. Any number raised to the 0 power is 1. So now what do we have? 4 times 4 is 16, minus 4 plus 1. So if I just group those, 16 minus 4 is 12, plus 1 equals 13. Okay? Remember, if I have 3 to the cubed, it's this number times itself that many times. So this would be 3 times 3 times 3. Okay, let's review one more rule. What if I have 3 to the second power times 3 to the third power? What's the rule? Okay, the rule, I have a to the m times a to the n. Have the same number, just like this. A in this case is 3. M is 2. N is this 3. So this equals a to the m plus n. So if I have 3 to the second power times 3 to the third power, that equals 3 to the 2 plus 3. And that equals 3 to the fifth. Now we could do this a different way. We could say, how many 3's do I have multiplied by each other? And I have 2 of them. So this is 3 times 3. And that's times 3 times itself 3 times 3 times 3 times 3. That equals 1, 2, 3, 4, 5, 3 to the fifth. Ah, looky there. So there's other ways to do that. But that's the rule. A to the m times a to the n is a to the m plus n. Okay, we said a to the 0 equals 1. What if I have a to the m divided by a to the n? That's a to the m minus n. Okay, so now 3 to the third power divided by 3 to the first power. Now we know that's 3 times itself 3 times, 3 times 3 times 3, divided by 3 times itself 1 time. That cancel, that's 1. 1 times 3 is 3. So what does this mean? That's 3 to the second power. 3 times itself 2 times. Now then, using this rule, I would say I have a to the m minus n. So I would have 3 to the third minus 1. And that would equal 3. 3 minus 1 is 2. Hey, looky there. So those are the 3 exponent rules that we've learned so far. A to the 0 is 1. A to the m times a to the n is a to the m plus n. That if I'm dividing a to the m divided by a to the n, it equals a to the m minus n. And then tonight we learn we have the square root of x times y. That also equals square root of x times square root of y. I'm a rules guy, okay? These, if you can master the rules, you can play the math game and play it well. Okay, so that's it for tonight. Why are we doing this? Hey, together let's build a better tomorrow, and let's do that through math. Study, 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 and we'll talk to you next time. That's all for now. We'll talk to you later. Thanks. Bye.